In this video, we're going to start looking at the language SL. Um, so the way that the textbook goes about this is it does things in like what you might call the logical order. So it starts off with a formal definition of what a sentence of SL is, right? Giving a precise account of what the sentences are, and then it goes through and it starts explaining what the sentences mean. So it gives a precise account of the syntax of the language first, and then it starts explaining enough of the semantics of the language for you to understand how to start translating English sentences into symbolic logic. Um, yeah, I mean that's the sort of logical order, but the thing is that that's not actually the way that the human brain works. Right. The human brain evolved in order to, identify resources across a wide range of environments and learn how to exploit them. And what the human brain is extremely good at is pattern recognition. It's not particularly good at sequential reasoning. We can learn how to do it, obviously, but it's not something that we're exceptionally good at. One thing that we're particularly terrible at is, memorizing a precise formal definition and then applying that to individual cases to see whether they fit the definition or not. This is just not the way that the brain works. Um, so, the way that you actually, want to learn how to, recognize what the, well-formed, grammatically correct sentences of SL are, the best procedure for doing that is basically the same as the best procedure for recognizing grammatical sentences in any other language that you would learn. You look at a whole bunch of examples of, grammatical sentences in that language so that you get a sense of what the grammatical sentences look like, right? What those patterns are. And then you'll learn how to identify those patterns in novel sentences, because that's the sort of thing that the human brain is like fantastic at doing. Um, Together with, of course, certain rules, right? And sort of admonitions telling you particular things that you need to watch out for. And then, of course, correction, right? Where your own attempts to produce grammatical sentences get, corrected. This is the way that you learn any language, and this is the way that learning logical languages works as well. So that's the way that we're going to do things. We're going to go through, we're going to talk about we'll start by talking about the language itself, the various components of the language. Then we're going to go through the meanings of the different connectives, what they mean, how you would use them to symbolize basic simple English sentences. And then at the end of all of this, we're going to circle back to the formal definition that the textbook gives in section 2.1. So that is the plan for like the next, I don't know, 5 videos, something like that. Okay, so if you remember from the last, the previous video, right, we drew the distinction between the object language, which is the language that we're talking about, and the meta language, which is the language that we're using to talk about the object language. So our object language here is SL, which stands for Sentential Logic. The meta language is English augmented with meta variables P, Q, R, and S. And notice that these are in boldface, right? So they're not just regular capital letters, they're boldface capital letters. It's possible for them to have numerical subscripts. I am pretty sure that we never actually do that because we never need more than 4 in the material that we're covering, but it is possible if you ever needed to for you to put numerical subscripts in. These meta variables are used to stand for any sentence of SL. So they're exactly like variables that you would find in algebra, except instead of standing for numbers, they stand for sentences. Remember the distinction, this was also in the previous video, between use and mention, right? To use a sentence is to communicate information with it or perform a speech act with it. To mention a sentence is to talk about it. So when we mention a sentence of SL, then it'll either be displayed, so it goes on its own line and it gets indented like this, or it gets put in quotation marks. I have a thing that I do where when I'm talking about sentences in formal logic, I tend to put them in single quotes. And when I'm talking about or mentioning sentences in natural language, I'll put them in double quotes. There's no real reason for this. Like, this is not a standard convention or anything. This is just something that I do. Um, okay, so here's your language SL. These are the symbols that it contains. It contains sentence letters. These are capital letters. They're not boldface letters, right? Those are the meta variables. So regular non-bold capital letters that can have numerical subscripts. Um, there are infinitely many of them, of course. There's sentential connectives, these five here, and parentheses. We're going to go through each of these in turn. So first, the sentence letters. Right. So the sentence letters, they represent logically simple sentences of English. Um, they can have numerical subscripts. This is so that we have infinitely many of them and we don't run out. They cannot have letter subscripts. Remember this: you can use numerical subscripts, you can't use letters. The reason for that will become clear when we start talking about PL, because then in PL you have you can have a capital letter that is followed by a small letter, and if you also have capital letters that have letter subscripts, it just gets confusing. So you can't have the latter case, right? The only thing that you can have for subscripts are numbers. Um, okay. Sentence letters are also referred to as atomic sentences of SL. Um, what these represent are sentences that don't contain any logical vocabulary that can be represented in SL. So, like Socrates is bald, Aristotle is dead. That's Socrates. You can see quite a bit of forehead there. Some frogs are green. I like ice cream. Um, these well, actually, when we get to talking about predicate logic, you'll see like some is actually a logical term in predicate logic. So that there's logical vocabulary there in that language, but you can't represent that in SL. All of these are just sentence letters in SL because there's no logical vocabulary here that we can represent. Um, to give meaning to sentence letters, what we use is what's called a symbolization key. So symbolization key tells you what sentence each of the sentence letters stands for. So S, what this indicates here, right, is S is Socrates is bald, A is Aristotle is dead, G is some frogs are green, I like ice cream. Note the format here, it's just the sentence letter, colon, and then what it stands for. Um, then you have the sentential connectives, right? And there are five of these, right? This is there's some the well conjunction, disjunction, conditional, biconditional, negation, right? They stand roughly for and, or, if, then, if and only if and not. Um, what these are for is these are operators that you use to form longer sentences of SL out of shorter ones. So like here, you've got you have an atomic sentence here, right? Just a sentence letter, and you've made a longer sentence out of it by putting the symbol in front. This here, this stands for for not, the symbol itself is referred to as a tilde. So tilde and then sentence letter, that's a longer sentence. Here you've got, right, two atomic sentences, and then you've made a longer sentence out of them by putting this symbol in between, right? This is called a horseshoe. Same sort of thing down here. These are referred to as molecular sentences, right? Anything that contains one or more of these connectives. When you're symbolizing, one thing you need to be very careful to do is make sure that you symbolize logical words of English with the sentential connectives. These need to be symbolized with the connectives. You don't want to put them inside sentence letters. So, like if you have Socrates is not bald, for example, not, that needs to be represented with the logical operator not, right? Which is that tilde that we were just looking at. Right. You can't have Socrates is not bald as just a sentence letter by itself, right? This logical, the logical vocabulary here, that needs to be pulled out and represented with an operator of SL. Same thing with the and here, right? Here with don't, right? The and here is another not, right? This is something you would also have to represent with a logical operator. The last component in SL are the parentheses. The parentheses are used takes complex sentences and indicate how things are grouped, right? So they distinguish the subgroups. So here the parentheses tell you that this tilde applies to that entire subgroup there. Here the parentheses tell you that these are grouped together and this. Um, right now, I mean, what we can say actually is the parentheses work basically exactly the same as they would in algebra. Yeah, it's one of those things where it's actually a bit tricky to define exactly how they work, but it's quite intuitive because you've seen exactly how this is. You've seen how they work before. Um, okay, last thing, I believe this is the last thing, is the meta variables. So remember that these are the boldface capital letters P, Q, R, and S, right? So only those letters, and they have to be in boldface. These are not actually part of SL, right? They're not part of the language of SL. They are part of the meta language. They're variables that range over sentences of SL. And anytime you have sentences that contain these are not actually sentences of SL, right? So this here, right, boldface P, horseshoe, boldface Q, right, boldface P and B, these are not actually sentences of SL because they contain these meta variables. Okay, so that gives you a basic rundown of what the components of the language are. And then in the next video, we'll start looking at what the different components of the language mean and how you can use them to symbolize English sentences.